Oei. Chris! Zijn uw slides actief? Oké.
So you can still sit in the front or on the table as well.
En kan ik met mijn muis dingen zijn? Ah ja, perfect. Koen, geef me een teken als we klaar zijn. Yeah. All right, welcome everybody. Welcome to our 17th meetup already. Welcome to Unlocked. Thanks a lot to Unlocked for hosting us again, I should say. Robert, do you want to say a few words first about Unlocked and then we'll continue?
Yeah.
Speak into the mic.
Okay. Thanks for the nice microphone. Happy to welcome you all. Yeah, not all back, but some of you back after I think almost a year ago that we did the meetup last time. So as Unlocked, we are part of. Yeah, some of you will know the Explore group, part of the bigger Kronos group, and we're a team of 6. Fully dedicated Dart, Flutter, it's the only thing we do. So we love Dart and Flutter, so we love to host, of course, Flutter Belgium as well. Maybe to give a quick idea on everybody who's here, who is working with Flutter on a daily basis. That's a good number already. Who's working with, who worked with Bluetooth in Flutter already? A few hands. Okay, that's good, because there will be some more detailed talk on that. And okay, so that's great to see. I hope you all will enjoy the talks and have a nice evening.
Thanks, Robert. For those of you who wandered in here by accident, from the show of hands, I don't think anybody, but still, we do this every time. So who is Flutter Belgium? Flutter Belgium is Koen, Chris, and myself. We've been doing these meetups for 6 years now, Chris, I think, 6 years. Yeah, I think so. The goal of these meetups is really to create community, to make sure that us Flutter developers can learn from each other, talk to each other, give each other tips, share best practices, all that good stuff. And in order to be able to do that, we are always looking for people who are willing to talk, to give presentations about really whatever you're working with, whatever you've learned. They don't have to be super advanced topics. In fact, our next meetup is at Hoest. And there's a fair chance that there will be a lot of students there. So it will actually be really good to have some introductory lower level talks there. So if you're into that, if that sounds like something you might want to do, by all means reach out. We're still looking for a speaker. Also for the following meetups throughout the year, we're still looking for locations to host, and really come speak. Like the entry level is really low, like everybody's welcome, the topics are open, and really everybody can speak. So by all means, join us. We have a Slack channel that you can join. We have the meetup group, obviously. We have the LinkedIn group. We reached 700 members. 600 members this week, which is a kind of a milestone that we set, so that's really nice. And then we also have a YouTube channel where all of the videos that we record, because we live stream these now, they always are posted afterwards, so you can always rewatch a talk and see what exactly that plugin was that somebody mentioned, or that package. Special thanks for Altra, because you might notice that I'm talking into this really beautiful golden microphone, which was 3D printed by the lovely people at Altra, because we needed something to hold our DJI mic, so now I have a really nice microphone to hold, so thanks a lot. We already did this. That's an important one. We have some topics that are requested by the group which are open, so if you are still willing to talk but you don't really know what about, there are some topics open, for example Flutter Web, Add to App. If you know something else, by all means reach out on the Slack if there's a topic that you would like to see a talk about. Just post it in there, maybe somebody is really experienced in it and wants to talk about it. The QR code, it's also, the roller banner is broken. We'll show this one on the breaks. We know at the end of the meetup we always do a raffle where we do some giveaways. The plushies are all gone, I'm afraid. We asked Google for new ones already, but we haven't gotten them yet. But we do have something exciting to raffle off today, which is we have 2 tickets to C3 Fest in Amsterdam. It's a dev conference in Amsterdam. And they asked us if we wanted to raffle off tickets, which of course we want to. So you can win those, which is cool, of course, to win. We have some lightning talks today, as usual. First of all, we have Jessen talking about system overlay styling. William was going to give something about slivers, but that was the information we got, but it's probably going to be good. And then Chris is also going to talk about lightning fast tests writing. And then later we have our full programs. We have Unlocking Bluetooth by Pieter-Jan and Jonas from Unlocked. And then later we have Tim from Altra, who will talk about real-time events in Flutter. I already mentioned this, but that's only for later. Our next meetup is at HoWest in Brugge. On the 15th of May, so we're going back to West Flanders. We did that in December, I think. A lot of people showed up, which was really nice. So we'll be in West Flanders again. So all that's left, I think, is nope, not see you next time. Let's get started with the lightning talks, I would say. So Jesse, by all means. Need to stop talking.
Thank
Speak
you.
into the mic, don't point with it.
Don't point with it?
Yeah.
Sounds like other people pointed with it. But let's start at the beginning. All right. Am I loud and clear to everyone? Yeah. Okay. So my name is Jesse. I joined a company called Breeze recently. It's we're building a dating app, or we are building. It's already live for a while. We just went to Belgium, and we had some issues when I joined with System Chrome. I think most people probably have had issues with it. What's System Chrome? It's these things, your status bar and your navigation bar. And yeah, well, I'll just give us a quick summary about how we can style them in Flutter, and specifically how I solved the issues we had at Breeze. I won't be talking about iOS as much because it basically just works kind of, as long as you take into account your unsafe area. But Android, you need some special attention. So if you build if you create a new Flutter app from the template and you launch it, this is what it looks like. On the left, you have an Android 9 phone, and on the right, you have a Android phone running a modern Android version. You see that the navigation bar is black for both. Now, for older Android versions, that's fine. That's basically the default. But for newer Android versions, typically you'll want to use edge-to-edge rendering, which you can do in Flutter using this call, system chrome.set enable system UI mode edge-to-edge. It only does something on Android 10 Plus, doesn't do anything on iOS, doesn't do anything on lower Android versions. But as you can see, you still get the black bar, and that's because the default color for the navigation bar is still black. And to change that, you do this call, system chrome set system UI overlay style, and then you pass a system navigation bar color of transparent. And that looks good. However, on modern Android versions, you can also change your navigation method. So by default, you have the gesture navigation with the small bar, similar to iOS, but you can change it to the old style 3-button animation. And as you can see, we still have like a background color here, something you might not expect. And that's because Android does not like that the buttons are white here and the background is white. So if they didn't add this background color, you wouldn't be able to see the buttons. Let's test it out. So we can disable this this forced contrast by setting the system navigation bar contrast and force flag to false. And as you can see, as you maybe can't see, the navigation bar buttons are kind of almost invisible because there's no contrast. So you'll still want to enforce contrast yourself in some way if you do this. But typically you can get very far just by changing the color of the icons, which you can do by setting system navigation bar icon brightness. In this case, we set it to brightness.dark. All right, so that's the calls you can do, these two, very useful. But there's some ways that you can make it a little easier in Flutter. I didn't actually talk about status bar styling, but it works similarly. You can pass the icon color for the status bar as well, for the icons at the top. They're black here, but System UI overlay style also contains fields or properties to set those to light. There's a property in app bar if you're using material to set the system overlay style. It does also have some defaults. So typically it just kind of works. You can pass different status bar brightness to app bar if the colors are incorrect. And the other way you can set it is an annotated region. This is a bit of a weird special thing. It inserts this value inside of the layer tree in Flutter. And then the Flutter engine basically hit tests it every frame, once at the top of the screen for the status bar styling, and then once at the bottom of the screen for the navigation bar styling. So yeah, at Breeze, we have, as you can see, two very beautiful brand colors. The left one we call wine, the right one we call lavender. And as you can see, the contrast is different. For the status bar, we use white icons for the wine background and dark icons for the lavender background. And there's this is different for basically every screen. So you can't really just set it once or override it for certain screens, because, if one screen is pushed on top of another, you want the screen that's pushed on top to have the right status bar styling. So basically we apply this styling to every single screen. And to make it kind of more uniform, I created this thing, Breeze System UI overlay style. It's a lot of code. I don't expect you all to read it, but basically it has two properties, one for the nav bar icon brightness and one for the status bar icon brightness. And then it, sets all the properties. And as you can see, there's some special behavior here when mapping this to the Flutter System UI overlay style to handle Android 19 or versions under Android SDK level 19, which matches Android version 9. As I said, the navigation bar transparency only works for Android 10 and up. It's a little bit weird how this works. You have the status bar brightness there that only works for iOS, and basically it's the flipped version of your icon brightness, and then the icon brightness is only handled on Android. So yeah, bit weird how all this fits together. How do we use this style? So this is just a data class basically. I made this thing, Breeze System Overlay, which takes an overlay style and maps it to the Flutter overlay style, and then applies it using both the annotated region and also by overriding the app bar theme so that it works even if you have an app bar. If you don't have an app bar, it basically covers all cases. And then this widget I use, we wrap basically every screen in this thing. So yeah, if you are in a similar situation, I hope this kind of helps. Just two more slight, kind of related things. One is status bar transparency. I didn't talk about it because it's basically supported on all Android versions. It's supported since Android 5+, which is SDK level 21, which Flutter doesn't officially support. They call it the best effort supported versions. So basically, you probably shouldn't have to worry about it unless you want to be still compatible with those versions and also care about it looking really pretty. And then, so the one more thing about the annotated region, I already said it does like the hit testing. We kind of, let's see. Yeah, the status bar styling should kind of, well, the way we handled this, we had bottom sheets, and you kind of want your navigation bar to have the right icon brightness for bottom sheets, but you don't want it to affect your status bar styling. If you use an annotated region on the whole screen, it kind of overrides both. But since it does like hit testing, if you wrap it inside a safe area that clips out the top part of the screen, only the bottom part will use the value set in the annotated region, because that's the only part that gets hit tested. And you kind of get like a sort of inheritance thing where the layer that is below it gets used for the styling of the status bar. I think that was very confusing, but yeah, that's it basically. Yeah, I hope that helped some of you. I think that's my last slide, yeah.
About there was a property, is Android 29 or higher?
Yes.
And that's probably an A-weight that you have to do with the, or how do you know?
Yeah, it is. I kind of abstracted it away in the slide, but it's it just checks it on your using the, is it device info plus? Yeah. Yeah, and we cache it like somewhere, and then you can just access it easily. Yeah.
Say you have a Chrome OS laptop and you want to deploy a Flutter application on that. Can you play with the luminancy of the top bar as well? Does it work the same way?
Can you play with the luminancy of the top bar? The thing is, if you do edge-to-edge rendering, wait, do you mean the icons or something else?
The system status icons, for example, can you play the same way with the dark and light version of these, depending on the background of the screen that you're wanting to present?
I don't really know how it works for Chrome and stuff, but basically, if you do edge-to-edge rendering, you can draw anything you want behind the status bar and also behind the navigation bar. So yeah, just make sure that you like ensure contrast and stuff. I'm not sure if I got your question right, because yeah, okay, great. Anyone else? Nope. Okay.
Nope. Yes. Yes, now it is. All right. Hello, I'm gonna talk a little bit about slivers. So I had to make this screen, which doesn't look that difficult now. But I was in a love-hate relationship with slivers, as I'm usually. And in the end, I did need to use slivers. Let's hope it stays on top. All right. So what is this screen? This screen is built up of 3 lists. So you can open them and close them. It has a little animation opening and slide closing. That's nice. But the top 2 lists are paginated and the bottom one isn't. So that means if you keep scrolling down, it needs to load future widgets. So it does an API call. If I go down, down, you can see that it keeps scrolling, even though every time it only loads 20 widgets. But then I can close it. I can close the list 3, and then I can start scrolling on list 2, which is also paginated. And then, to top it all off, I want to have the header pinned to the top. So now the list 2 is on top, and then if I go back up, list 1 is there. So yeah, if I scroll in list 3, you'll see only list 3 is kept. And then I also want to have a pull down to refresh. So I'm going to show that quickly in iOS style, because that makes it even more difficult, because if you start dragging down, now the whole list goes down to show the refresh animation. So that also needs to happen. And then, yeah, automatically, of course, refresh the paginated lists. And then to top it all off, because I like a challenge, I want to do everything that only the widgets that are shown are actually built. So you'll see at the bottom, currently no children are built. So the list titles don't count. But if I open this one up, now you'll see 16, 20 widgets. But then if I go down, yeah, it stops. So if I now open every list, you'll see that, yeah, 26, 27 widgets are only built, and the rest is all gone out of my memory. So I can have, yeah, like thousands of items in the first list, thousands of items in the second list, and you can keep scrolling without any issues. So that was the challenge. And then I started and I thought, yes, this is something for slivers. And after 5 minutes, I said, no, screw slivers. But then after 10 minutes again, I started again with slivers. And that kept going for a while. But in the end, I did use slivers. So that's why I'm talking about slivers. But I did use the slivers tools package, because it's a pretty useful package if you do pretty difficult stuff. There are a few things you need to know. So the multi-sliver is a sliver widget that holds multiple slivers, which sounds pretty useless, but it's actually pretty useful for 2 reasons. First of all, you can clean up your code by creating a single widget that returns multiple slivers, which is otherwise pretty, yeah, if you don't do it correctly, you'll create a class which has a static method which returns a list of slivers. That's not nice. Now you can do it just one widget. And the other thing is the push pin children, so that's automatically pushing the other child on top, which is very useful as well, because otherwise they'll just stack all below each other. And then one thing you need to know is that the push pin children needs multi-slivers inside of it for it to actually work. Because if you don't do that, then you have the same issue that the pinned children are all just gathering on top. And then one other thing to know is, for the animation on iOS, so if you drag down, that the header is not actually coming, so that it is actually coming together with your list, you need to add an empty persistent header delegate. Otherwise, your first header will stay on top because you're just dragging the list, so it thinks, oh, I need to be pinned. But you don't want it to be pinned if everything is on top. So yeah, that's how that works. And then one last thing is the paginated lists. I solved it pretty easily with a paginated list and then just a visibility detector, unlike the fourth last child is just a visibility widget. If it becomes visible, then you need to load the other children. That's it. Yes.
I think it's really cool you were able to build something like this, but I do wonder what was the use case for it?
It's massively overpowered. It's the use case is we have members for, think about Facebook. You have a group. In that group, you have members. So the top list is all the requests of the new members. The second list is all the members that are in your group. And the third list is all the blocked members. So they're expecting thousands of users in the list, but there are not thousands of users of the app at the moment. So it's a little bit overpowered, but I wanted to do the challenge and build it so it works.
3 tabs, you thought, I'm going to put everything on one screen.
Yes. Any other? Yes.
So you said that multi-sliver, you could actually put everything together into a separate widget.
Yes.
I'm not sure, but can you wrap other slivers with widgets as well and still include them?
Yeah, but the issue, for example, you can put custom lists, I think, in other custom lists. I'm not sure, but then you can put like a text to box, sliver to box adapter around it. But then you lose all of your builder mechanics. So I only want the widgets that are currently on the screen being built.
But
And
you
because
you only lose it if you only lose it for the one where it's in the sliver to size.
yeah, but I've got
Yeah,
3 lists, so I wanted a widget separate for each list. So yeah, I did it that way.
It's not that from the moment you add a sliver to box adapter, everything below it will not use the builder anymore. That's not the case.
No?
Okay.
I think it is, but I'm not sure.
Yeah.
The thing is, if you use a sliver to box adapter, it needs to know the height.
Mhm.
So I think it will actually build all of its dependents.
Mhm, mhm.
So that's why.
I wasn't sure because I haven't tested this, but I think you could actually put one sliver into a separate widget, but it should be a render sliver that is rendered and it can't have a render box above it.
Okay.
I think a widget doesn't have any render object specifically and passes on the child, so then you can do it, but you lose the functionality of having multiple
Yeah,
slivers, and
yeah.
this seems to solve this, I think.
The biggest issue is slivers are a bit magical. Nobody knows exactly how they work. So the multi-sliver works, so I'm using that.
Fun fact, the list view builder itself is also a sliver.
Okay,
Fun fact. Cool.
fun fact. Thanks. A question there?
Thank you for your very interesting presentation. I actually had a question that has nothing to do with slivers. I was wondering
Shaders?
just wondering, how do you keep track of which amount of widgets have been built?
Yes, that's something I looked into this morning because I just made this today, and it's actually pretty dirty, but it works for some reason. So I created a user widget that's stateful, and I just put it inside of my global view model. Hey, I'm built, and hey, I'm disposed. And that works, but then the issue is you have your init and your disposed state, so you can't update the UI during those functions. So to solve that issue, I have a periodic timer that keeps running and keeps updating my UI just to propagate the changes. This is not production code. But it's just for the demo and it works, yeah.
Nice.
Yes.
Just a comment, you actually have a version of multi-sliver in Flutter itself right now. It's called Sliver Main Access Group.
All right.
They added it
That's a bad name.
a few months ago. I like multi-sliver better as well. Yeah.
Yeah. Okay. Good to know. No other questions? All right.
All right, not this one, of course. Hello. So I wanted to show something maybe useful for you about test writing
well, every time you start writing tests, you always think, oh no, this is going to take way too long, probably. So to give you, I just created an example project, the really basic one, where you have the plus and it counts. Now I'm just having a look at the basic tests here. It's already there. What does it do? Yeah, it does very simple thing. It presses the add button and it checks if there is a 1 in the center of the screen. Okay, but of course, here we knew what happens, but what if we do this? What will be the outcome? What can we do? Okay, we can run the test. Yeah, it will fail. But yeah, we don't know actually. It's not 1. That's all we know here. We can count the lines, of course, but that's not. In testing, it's always it's broken, and I don't really see what's in there. So what can we do here? For example, what can we do? Like for example, debug dump app is a possibility. Just run it again. That's an easy way, but now we can have a look at the tree and look, where is the number? No, we don't like it, of course, but been there, done that, I guess. What is maybe already a step further? That is debug. What is it called? Dump. Semantic tree, for example. Let's run it again. All right. Now the semantic tree is a bit. It's a bit smaller. Maybe somebody already saw it. Here, it's 60. Okay, that's we already knew it by now. But another way of actually doing it is, instead of debugging this one, we can I just copy paste my code here because it's actually create a golden image of what we see at that moment. So at this moment you can't really run the test via the normal run command, but you have to add a parameter. The easy way is flutter test dash update goldens, the test will go on and it will create an image of the almost there. No, we don't see it. Okay, but it's not completely useless. If there are like overflows somewhere, you can already see it here. Why it's overflowing? Because the font during testing is a very big font. That does not always happen in your own application. So it's useful, but no, we can even do better. What we can do here is, for example, I created a snippet. Where is the launch JSON? So here it defines every command that you can run in VS Code. What we can do here, I will explain later, is adding something like this. Save. And now, no, not this one, of course. Now what happens here? Oh, there's something behind the lines. Okay, let's run it. Let's wait a bit. And what it's actually doing, well, open anyway, of of course it's failing. It's actually running the test inside of a real application. It's all useful, we can see. But the good one here is you can actually just, oh, it's 60. Okay, let's fix the test. Allow and restart, and it will instantly restart, and the test is gone. It's okay. So here also a good one. If you still had an issue, for example here, it will crash again. If you, for example, pressed the 60, then in your debug, oh, did not work for some reason. Because I have to, yeah. So the thing is, when you press the 60, it also shows you, oh, which stuff are you actually maybe looking for. It helps you with some code that you can actually add here. So that's, I think, a very useful thing to the fact that you can actually write stuff here, press the restart button, and instantly see if it's working or not. That's it, I guess. Question?
Yes. Thank you so much for showing this. I didn't know this was possible actually.
Mm-hmm.
Can we actually, during the test, set multiple breakpoints also to check the state where it's at?
Yeah. You can just use debugging like you can use in another thing. The part I forgot to explain, I guess, is the magical script I added. I can share it, of course, in Slack. I use it a lot in our projects here. So what it actually does is it registers the test. Here is the title. You can change it to whatever you want. And the CWD command thing is actually a path to a Flutter project. So if you are actually in another package, which is not a complete Android iOS application, it's just a plugin or a package, then you can link this one to // to another project, which is a Flutter or an empty Flutter project, and then it will just use that project to spin up the test. So it's not only here. The basic example is actually inside the application with the Android and iOS folder, but that's not needed. Yeah. Yeah, so launch. This is the most important one, I think. And yeah, this one here is default, but you can change it. And here you define that you can run and debug the code, but actually I always choose debug. That's it. Right.
So 3 really interesting lightning talks. So feel free to give the lightning talk yourself in the future. But now the full talk. Peter Jan and Jonas will be talking about Bluetooth. We had one talk about Bluetooth before, I think 1.5 years ago from Paulus. And yeah, I feel like it's a topic that's becoming more and more used, more and more important. So another look on how Unlocked took the challenge to use Bluetooth. Are we good to go? Then take the stage and
All right, thank you. Great, thank you all for coming, being here in such big numbers. Today we'll be talking a bit about Bluetooth and how we're trying at Unlocked to unlock Bluetooth. We'll start with just the agenda, bit of introduction, who are we, what are our experiences with Bluetooth, what challenges did we face trying to solve as well. We found a solution that worked for us and how we're building that solution, extending it into the future. So who are we at Unlocked? Well, I'm Peter Jan. I am a inline skating, sport climbing, D&D playing Java developer who turned Flutter developer. I started out at Unlocked about 1.5 years ago, I think, and then converted myself from Java developer to Flutter developer. And with me is...
Yeah, so hey everyone, thanks for the transition. So I'm Jonas. I'm one of the co-founders alongside Robert of Unlocked, where I in day-to-day take up the role of technical lead, where I do technical excellence, like we like to call it. And pretty much like Peter Jan, I also come from a history of Java, among other things, also with a passion for mobile apps and the full spectrum of providing multiple applications across multiple screens, which leads us to Unlocked, where we focus on all screen applications and where we try to provide our customers with a digital experience where they can have impact on their clients and help them connect, if necessary, to their interactive devices, which we use alongside, among other things, Bluetooth to connect those devices. A little bit about Unlocked, as Robert mentioned earlier on, we are a team of 6 people. We are based from Leuven and Contig mainly, and we are part of Explore Group, which is a group of a lot of companies, as you can see, around 54, about 1,100 people, maybe 1,200 maybe nowadays. And along that, we are part of Kronos, which maybe all of you guys already know, and might be part of, actually, which are even more people, 9,550 more competence centers. And as you can see, we are spread out across Europe, mainly on a lot of locations.
Yeah, so we'll be talking about Bluetooth, as we said before, but maybe just a quick refresher on what Bluetooth is and that kind of stuff. But I'm not going to do the original talk about where the name come from and all that kind of stuff. No, you can read that on Wikipedia. We'll just talk about devices. We'll talk about a lonely smartphone that is all by itself, looking for someone to connect with. And sometimes you can search and you can find someone, and then you can wait until the transition is over. And it's loading.
It's freezing.
It's freezing, that's not good. Murphy is in the building.
Just give him a moment.
Yeah. Who, Murphy? Or no, it's proper freeze.
No, he's still alive.
Still alive, okay. So we try to look for devices that we can connect with, and usually it's just small connection. We can pair with, let's say, a headphone, and we can start listening to songs or do something else, and then and then maybe sometimes we need like not just a small connection, but something really proper like a bond, and then we, instead of pairing, we'll bond with two devices. And then it would be useful if we could go to the next slide, but
Yeah.
no, okay. So we pair, we bond, and then eventually we try to actually do something with that bonding as well. We'll need to read some data from it. We need to store some data on the Bluetooth device. For instance, I have a smartwatch here, and I want to I want to know how many steps. Oh, there we go. Okay. Okay. Yeah. So at the end, we're properly bonded, and we can do a lot with it. We can read data from each other and write data as well. So how does that happen? How do we read data? How do we send data to a device? Well, let's make an analogy here. Let's say that our Bluetooth device is like a big store. And then we have in that store a couple of departments. We have clothing department, electronic department, and maybe also food. It's also useful in the store. And those are our services. So our Bluetooth device has certain services. And within those departments, we have shelves stocked with products. And those are our characteristics in Bluetooth. And when we're walking through the store, we go to a certain service and then to a certain shelf, and we take out one of the products of that shelf and we read our data from our characteristic, or we store something in that shelf and we store something on that characteristic. So that's all fine, and then we can do everything that we want. Now, quick question, Robert also hinted on this. Who has used Bluetooth before? Okay. Who has used Bluetooth within Flutter? Okay, less hands. That's fine. We use Bluetooth as well, and we have our experiences.
Yeah, indeed. We have done quite a few projects. We've done a lot more projects, but these are some of them. Obviously, for obvious reasons, we're not showing application pictures. These are AI generated, but you get a hint on what it does. So the first one of our cases that we have done for multiple cases actually is smart bicycle components for shifting, updating of the firmware, putting on settings for them. One of them on the right you can see is for a medical appliance for glucose sensors, where we have done those. We have done for sport competitions, for time tracking, for an external Bluetooth enabled clock, which needs to be performant, has to be low latency. And then, of course, Moon, which is right in front of us. In its final version, it's a lot nicer. This is the bare bones version, which you will see later on during this presentation come up again during our demo.
Yes. And in these projects, we used a couple of packages. We had a bit of different experiences with them. We used QuickBlue in one of our projects because it needed to run on desktop. You needed to run mainly on desktop, so that's why we used it there. It did have some limitations on Linux and all that kind of stuff, but it worked fine. There's a new kit on the block as well, Universal BLE. It's quite new. It's only maybe a month old, but has quite some promise, I think, because it's also multi-platform. Did experience some issues with it on Android, where we were subscribed to one of the characteristics. So we were continuously looking at one of the shelves, and we sometimes lost some data from it, which isn't all too good. The package that we use the most is Flutter Blue Plus, because we didn't have really that many hiccups. Sometimes we did experience some things with versioning that went wrong, that were breaking changes, but weren't versioned as breaking changes. So we had to deal with that as well. But yeah, that gives us a couple of, how would I put it, challenges that we need to tackle and fix. And one of those main challenges is mocking all this behavior, all this Bluetooth behavior. sometimes we don't have access to real devices to connect with our Bluetooth Moon, for example. We're on the train, we don't have the equipment with us, we just want to run it in an emulator. So we had to figure out a solution for it. Also, if we just wanted to swap out one of the packages, we couldn't just do that. We would need to refactor a whole lot of our code, and that's not easy to do it. So enter our solution, unlock Bluetooth. Soon to come. But I'll hint on that in the future. So a bit of history. We started out with just, we want to use Bluetooth, we want to use it in an emulator, we want to use it in unit testing, golden testing, all that kind of good stuff. But how do we do that? Well, we just took one of the packages that I mentioned earlier. We used Flutter Blue Plus. We took it, we wrapped it around so that we have a bit more control. And then we started mocking. And the mocking at the beginning was pretty straightforward. We just put JSON files on an emulator so we can read out that JSON file, and then our mocked code could just see, okay, need to fetch that data, do something with it, and show it to the production code. But soon we experienced some growth pains, and we wanted to expand that. So what do we have right now? Who has used the hexagonal architecture before? Who has heard of it? Just two, maybe? Okay, that's fine. Well, pretty straightforward. It's a central core. We called it the controller. And that is a part that we expose to our production code. It exposes all the methods, so it exposes a method to connect with a Bluetooth device. It exposes a method to read a characteristic, to read a service, to discover services, all that kind of stuff. And then on top of that hexagonal structure, we started to add adapters. And it's all different kind of implementations of basically the same thing. And we defined a way to just switch between it. So we have a Flutter Blue Plus adapter, which is one implementation, and then we have an ISR implementation, a fake implementation, and we can just easily take out one part and plop in another one depending on our use case. So for instance, if we have unit tests, we just take out the Flutter Blue Plus one because we don't have an actual device, put in a fake one, and we can continue with our golden tests and have control, full control about what we're doing. And now we're expanding that even more. We're actually dabbling a bit with DevTools.
Yeah, so I suppose that everyone here has already used DevTools. Maybe show of hands. Yeah, okay. So you're all familiar with the VM service, which allows you to communicate between actually your application, which is running, which connects to DevTools, which is in fact actually a web application which runs in Chrome, whatever you're using. And now you have this communication layer, which is a protocol to allow you to put on breakpoints, for example. So it sends an action, we're going to breakpoint on this execution of code. So we also want to do that, and now Flutter allows us to actually extend on DevTools, like Koen already also has done. So what did we do? I'm going to zoom in a moment, don't worry. So as Peter Jan said, we have a controller, and here we have our VM service, which connects to our application. If you look at what our control really exposes towards our adapters, are actions that it can do, like, for example, turn on our adapter, turn it off, list our system devices, all of these connections, all these actions that you want to take. You might want to just visualize it in your DevTools, because you're debugging, you want to see what's happening, what's scanning, what's going on. We can also see events happening, like the adapter has changed. It's now offline, it's no longer connected. We can see it in our DevTools. We can also, of course, get responses like, oh, turning it off went wrong. So it's an error that's actually happening. And this is all possible due to our abstraction of what we call a DevTools connector. What is this? Every one of our adapters actually implements it, and then he initializes itself and registers himself with the VM service. So your app uses our adapter, like Flutter Blue Plus. He initializes and registers himself with the VM service, and now we can actually send or receive actions, events over that protocol. Pretty much like method channels, if you're familiar with that. So our actual Control DevTools extension, which is part of your DevTools in your browser, can now also request actions like turn it on, turn it off, and it will send it over the VM service, get it to the Flutter Blue Plus, for example, on your real device, turn off the actual adapter. If it's a fake one, then obviously it does fake data or fake actions. So that's pretty much what we are doing right now. At this point, it's a work in progress. We have a few things working, like turn it on, turn it off, the adapter that is, listing the actual system devices which are currently connected. And if we move on, later on we'll show you what the actual future brings for that.
Yeah, so let me try to switch here real quick. See if this works. We know that Murphy is in the building. Output. Black screen, that's fine. And there we are. There we are. Okay. So I currently have two applications running. The one on the left is an emulator. So it has less functionality than the one on the right, which is my tablet that I have just here. What I first want to show off is our DevTools that Jonas was just now talking about. We added a extra. Oh, I need to zoom. Can I zoom? I can. That's better? Yep, now it's hidden. So we have our own little tab in here, which we just made this morning. And in here we have some information about the current adapter that we're running. So this is my actual device where we are using the Flutter Blue Plus adapter, and my Bluetooth is off at the moment. I don't have any system devices, so I'm not connected with anything. From here, we can toggle the adapter.
Now you have the pop-up.
Now I have the pop-up. I can press allow, and I turn Bluetooth on from within the DevTools. Eventually, we want to extend that functionality, do more stuff with it, but future stuff. Let me first show you the moon. So I'm currently finding two moons. One is in front of me, one is all the way in the back. And let me see if I can find the correct one. We can say real data or fake data. The whole thing about the moon application is that we can actually show what the moon is like in a lamp form. So if I were to choose real, then it would pick up what my location is right now and then do an algorithm, see what the moon should be like. Is it half moon, full moon? But for now, I'll just use the fake data. And let me see if I change something here. Does it change? Yeah. It is changing. Great. So this is proper Bluetooth connection directly with the moon. I can change, and let me put it on half, and then change the angle as well. I saw it change here, so that's good. I'm not going to toggle the brightness because otherwise you guys are blind. And then I can press done, and I have here one Bluetooth device that I'm connected with. Let me do a quick refresh here. Oh, it's not in here.
It's Murphy.
It's Murphy, thank you. Okay, that's fine. So we have the one device here. We can do kind of bit the same here. This is also the Flutter Blue Plus adapter that I'm using. I can turn on Bluetooth. I can get the pop-up. It's looking for moons, but it won't find anything because it's an emulator. So what I want to do right now is actually swap out our Flutter Blue Plus implementation and use the NICER implementation, a local database. So let me check and see. Yes, this is the code. Let me put it a bit bigger for you guys. So I'm gonna switch out the adapter, put this one in comment. This is our Iser Bluetooth adapter. Let me just do, this is the wrong one, thank you. Let me just restart this one. Go back. Bluetooth is turned off. Let me turn it on. Takes a while, we don't get the pop-up because I'm actually changing the database locally. It was searching and I found something. This is just a device that I configured myself, which is stored locally on the device, which I can also change if I want to. I can do the same thing. I can connect with it. I can read out data that I stored on it locally. I set the brightness to 2, the daytime brightness to 8, and I can dabble with it if I want to. I can set the percentages, I can set the brightness. I can do this one without blinding you guys. And then I can store it as well. And then later on, if I want to connect with it again, I can do it all day long. So I can use the emulator, or I can write a unit test for it, a golden test, and I plug in anything that I want so that I can have a safe state and know what kind of data is present in my golden test and properly test for it. What do we want to do in the future? Now I need to switch back.
Yeah, is it still alive?
Is it still alive? It is. Okay, oh, there we go. Sorry for the transition. No signal. It popped here. We're doing something. There we go. So what do we want to do in the future with this? Well, we want to release this to PubDev so that everyone can enjoy this. Before we can do that, we still need to clean stuff up. We need to write a proper README. We need to provide some testing, examples, all that kind of stuff. We want to extend our DevTools functionality. What we were thinking about was, for example, that we have 2 adapters running at the same time, the Flutter Blue Plus and then the fake one. And we want to copy the state of the Flutter Blue Plus and store it in the fake one so that later on we have an exact replica of Bluetooth devices in our emulator, so that we can just test with that one. What else do we want to do? I just toggled the Bluetooth status on and off. I also want to see what kind of scan results I'm getting. Well, I'm actually scanning so that I can see what is happening real life in the DevTools and then compare it with what is running in my application. Then we want to add more adapters. So we highlighted 3 packages earlier. We only have 1 adapter for it. It's the Flutter Blue Plus. We're working on the universal BLE, but it needs some love at this point. We have an Iser one, we have a fake one, but maybe we can think of other examples that we want to write an adapter for, other use cases. So we want to write those. And then, yeah, we want to extend the current functionality, which is basically the thing that I said. Universal BLE isn't working properly, so we should fix that one. But that's all stuff for the future. For now, this is all we have. I want to thank you all for listening, and we love Flutter.
Emulate some noisy environment or something.
Ooh, yeah, that's also a good idea, so that we can, if you have an emulator, you could say, okay, the next connection will drop, or you can't connect with it, or maybe there's a delay or whatever. Yeah, yeah, good idea, thanks.
Since it's not possible to use Bluetooth from an emulator, would it be possible to have an adapter that actually uses the dev machine as a connector to?
Ooh, that's so the question was if we could make a bridge between the emulator and then the Bluetooth on an actual dev machine, and then see if we can use that connection. That's something that we could look into.
Yeah,
perhaps?
the adapter couldn't run on your actual application, right? Because that would be in the VM, in the simulator environment. Then you would have to actually use it from the environment as the DevTools is running.
Yeah,
Mm.
that's
Yes.
that's
Nice challenge.
nice challenge indeed. Yes.
How do you ensure that the mock data that you have inside the emulator works in the real device?
So the question is if the mocked data that we're using in a device, how do we ensure that it's proper data, right?
And whatever the changes you do, how do you know that it's actually something that it will work once it's connected to the device? Do you rely on actual devices when you're making the test first?
Yeah, so for this example, we first made the proper implementation with Flutter Blue Plus, and then we were like, okay, let's copy that data. We know what services and what characteristics are available on the Bluetooth device. We'll just copy that over, and we know what data to present to the device, or to the application rather.
Okay.
Wouldn't it be easier to write a decent Bluetooth package instead of writing load adapters for all the 6?
That's probably also a solution, but yeah, this way we also had the flexibility because one of the core problems that we had at the beginning was emulators. We don't have a solution for emulators. We can use Bluetooth in some way. Maybe we could write a bridge to it and include that into that package. But at that point, we could just also make different adapters and have the flexibility to say, okay, we don't want to maintain the Bluetooth stuff or the Bluetooth adapter ourselves. Let's just use something from the community.
I think also the main point was like, okay, we all know how to mock API services. That's easy, but then we're like, okay, we want to mock our Bluetooth interfaces as well, so that we're not always depending on connecting to real devices.
All right. Yep.
Thank you very much for this super interesting presentation. I learned quite a few stuff. My question has nothing to do with Bluetooth actually. I have no idea what inline scaling is.
Inline scale, rollerblading. Yeah.
That's the best question so far.
Yeah. That was an easy one. All right.
All right, nice. Let's have a 10-minute break. right. So yeah, really nice talk. The first one. For the second one, we'll be talking about events occurring in real time and everything around it in Flutter. I think also a little bit of backend was included. So full stack today. That's cool. Something different. So please enjoy and take the stage.
Yes, so I'm Tim. I'm a senior developer tech lead at Altra. And I'm a pretty newbie Flutter dev since a week or so don't ask me hard Flutter questions. My background is more in web. I was pretty involved in the Umbraco CMS in the early years. And something that was always really hard was adding real-time functionality to an application. But now, after today, you'll know that adding real-time functionality is as easy as punching through a styrofoam board. Meet Signal R. Signal R is a project that's been around since 2011, was started as open source, and has been part of the .NET project in 2013. It allows server code to send async notifications to client-side web applications. Still a bit in the web atmosphere. It takes advantage of WebSockets, but it falls back if those are not available. So what do you need to know about Signal R? It's .NET, so it's open source, cross-platform, and it's an abstraction layer on top of WebSockets, making it a lot easier. It introduces the concept of hubs, which I'll show you a bit later. So most of you are used to communicating through REST, so you send a request, you get a response back, and that goes back and forth. But with Signal R, you do basically a handshake, and then you have a persistent bidirectional communication channel with the server. When would you use this? For example, for live chat rooms, data broadcasting like traffic updates that you want to see instantly, multiplayer collaborations, notifications across social media apps, like live GPS locations, for fleet management, and a lot of other stuff.
Okay, let's go.
And what I made as a proof of concept is the Turbo Polyp reservation app. Turbo Polyp, you say? Turbo Polyp is a fair attraction which has been quite the meme some years back. You have one guy which is called Michael. He's like a really fair fanatic, and he made the fair at home, and his top attraction was the Turbo Polyp, so there's a YouTube video about that. And like 5 years later, they discovered there's another guy, Yuri, who has the same hobby. So they both have that hobby and just do Turbo Polyp together. You need to watch it. So the Turbo Polyp reservation app, basically you get an overview of all seats, but of course the Turbo Polyp is super popular, so there's only a limited amount of seats available per day, and once a seat is taken, it must be unavailable for others immediately. That's the concept. I'm not a designer, but this is the server, which contains .NET backend. The API REST API to fetch all of the seats, the Signal R hub, reservations are stored in the database, and then from your Flutter apps or your web app, you can make the reservation, and the reservation will immediately reflect on other screens. So the backend, again, is just a DB table with a unique ID, which number the seat has, what the time slot is, and if it has been taken or not. Simple model, ID number, time slot taken. And of course, we need to fetch the data with a repo. So getting today's seats, if there aren't any seats found, it will just insert the seats with a simple algorithm and an option to reserve a seat based on the ID. And then to fetch the seats, this is just a REST web API, and just get the seats in a JSON format.
Okay, let's go.
So that's all pretty standard stuff. And what Signal R will introduce is the Signal R hub. So the hub is the way to interact with Signal R. And you can see you can just use dependency injection to insert stuff and then create your methods. For here, the clients will basically invoke this method. Then it will use the repository to reserve the seat and send an async call to all connected clients to invoke a block seat method with the seat ID. And the rest that is still to do, besides creating the hub, is just registering the hub so that you know at what location you can find it. The web app is pretty simple. We just connect. This is just plain JavaScript. You see we just connect with a certain URL. Start the connection. Is there an error? We just log it. And to invoke, this is a lot of code, but it basically just invokes the reserve seat method on that hub, providing it the seat ID, which was found by looping through all of the seats. And then, yeah, it invokes it and shows an alert. And you can also listen. So whenever the block seat is invoked from the server on the client, we will just look for the seat by ID and add the class taken to it.
Okay, let's go.
So maybe now for a short demo, and it's an interactive demo. If I can find. So in the Slack of the Flutter community in the general channel, I just placed a link, which is the web app. So that's the first step. I did not load test it. Shit. And normally, if people start reserving seats, you will see that the color changes. So that is the communication between clients going. You see, that's the concept. And now, of course, we want to do this in a Flutter app. How do we do this? There's a package, signalr.net core, which we can just add as a dependency, which you do like this. I'm new to Flutter, so yes. How do we connect? That's also just importing the package, saying where your server is. Yeah, I'm now just using an ngrok tunnel to forward to my server. And then we need to know which hub we want to connect to. That's it. Now we have a connection. No. We have to start a connection. But this is a method in Flutter, private, I have been told. Of course, now we can invoke methods. And how do we do that? Pretty similar to how it's done in JavaScript, just a hub connection, invoke the name of the method on the hub, and provided the arguments. And we can also listen. So whenever the server gets that reserved seat, it will broadcast a block seat. So we can say, well, on block seat, well, use this method to handle that. And you see here, it does that. From the parameters, the first is a string which contains the seat ID, and then we can start doing stuff with that.
Okay, let's go.
The demo. It's open somewhere. Yes. I'm not a designer, I said. So these are all the seats. They have all been reserved. So I think I need to reset the database. So now I will just update so that all seats are not taken, and then reload. Yes, you see now somebody is clicking and it's being updated. I can also click and it will be updated. Interactive, super easy. Like I said, adding real-time functionality is as easy as breaking a styrofoam board. Nobody had styrofoam, otherwise I would just punch it here, but I tried, but yeah, it's bad for the environment. You can find the code once I upload it here. If you're interested, it's basically a starting package to get up and running with it. And that was the talk. Maybe it should have been a lightning talk, but
Okay, let's go.
yeah.
Oh, wait.
Comparing these two alternative methods, why should we use this one?
Because I come from a .NET background and I was super simple, and you see it's just really easy to do.
Okay.
So it's why look for hard solutions when it's easy. And it's been around for years, so it's a proven technology and stuff.
Yeah, but so are WebSockets. And
It's built on top of WebSockets.
ah, that's a good reason.
It makes it easy.
But what SignalR does is add extra functionality on top of WebSockets. So if WebSockets aren't available, it has
A
deploying
fallback, yeah.
for
Okay.
that, for instance. So depending on the type of connection that you have, it will use another communication technology. So with WebSockets, you're one-on-one linked on whether WebSockets are available and the browser version and whether it has been updated. And this one has a fallback up to 11 years ago, so
Yeah.
even Internet Explorer.
And by default, it uses JSON to send, but it can also be configured to use message pack, I think. So you can have a lot smaller packages to send.
What if you're not using .NET? Are there packages for Node, for example, or for Dart on the
But
backend?
.NET, you all use code, so why would you use
So the answer is no.
There might be, but not that's easy.
But it's not that there's a SignalR library for Node, for example.
No.
Oh. Okay. Nice.
It's mostly if you have already an existing .NET backend and you want to add real-time events, then you can choose this technology. If the backend developers don't have a lot of time or
Yep. Okay. Nice. All right. Thanks. Oh. There was.
Is there a clear advantage in using something like this over Socket.io?
Maybe, I don't know. I haven't looked into Socket.io, no.
Okay. Well, it's
that
also
might be, there's
like
a lot of comparison on the internet, but
it's also like a layer on top of
yeah, what I
WebSockets.
read, Socket.io is more like if you want to live stream video and stuff, really for data intensive stuff, and this is just for smaller packages.
Okay, all right.
More like that.
Thank you.